So in solving this equation, the square root of x minus 5 equals 3, you need, again, to determine what kind of equation this is to know what you got to do. So when I look at all of these ideas here that I'm about to write, the square root of 4, the cube root of 7, the square root of 8, the fifth root of x plus 2, the fourth root of 2x minus 1. These are all called radical expressions. Radical expressions. Okay, radical expression. So you see the word radical. So you know you're dealing with the radical, and you dealt with radicals when we looked at the other ones. The square root of 5, the square root of 16. Those were radical expressions. But the equation was not radical. The equation was what kind of equation we did earlier? Quadratic. Okay, now, these are radical expressions. So when you see the square root, cube root, square root, fifth root, fourth root, and so on, those are radicals. Now remember, the index, a radical has an index. So what I'm pointing to here, what is the index of this radical?
3.
Oh,
that 5?
Oh, yeah, I'm sorry. The 5 looks like a 3 up here. That's a 5, yes. So the index is the root part. So fifth root index is what? 5. What's the index here?
4.
4. What's the index here?
2.
2. Oh, not 1. How do you read this? The square root of 8. Square root. You didn't say 1 root, right? You said what? Square root. In fact, there is no radical with index 1. The smallest index is what? 2. So there's no index there. It's understood to be what? 2. So that's why you say square root, right? Okay, square root. What's the index over here? 3. And just see if you remember what it just said. What's the index here? 2. Okay, 2. All right. Whenever you write it like this, though, it is now called a radical equation. Why is that called a radical equation? First of all, it's called an equation because you see a equal sign, right? And it's radical because your expression is a radical expression on the other side. So that would be a radical equation.
And is that 2x or is that a 4?
That's a 2x, the fourth root of 2x minus 1. Okay, radical equation. Okay? So what we're going to do now is solve these radical equations. Now, the radical equations that you're going to see on your quiz or a test or the final will be square roots. They'll be square roots. So you won't have a fourth root, you won't have a fifth root, and so on. They'll be square roots. So let's go to this right here. Is this a radical equation? First of all, let me ask you, is it quadratic or radical? It's a radical equation. In particular, most students will just say, well, it's a square root equation, right? Because what's the index? 2. All right, so let's kind of review something, though. Let's suppose, I'm going to go off to the side. Go off to the side. And let's suppose I had this. Now, listen carefully. You can do this by inspection. The square root of x equal 3. Square root of x equal 3. You can tell me what the solution is. Square root of x equal 3. What is x over there? Oh, I thought y'all could. Oh, I'm disappointed. 9. Square root of 9 is what? 3.
Oh, legit.
Lord. Oh, no, I know it's a long day. You're like, I'm hungry. The square root of 9 is what? 3. So what's x? 9. Okay, x is 9.
I know he was legit asking for what X equals.
So x is 9, right? Because the square root of 9 is 3. Because 3 times 3 is 9. Now remember when we did the I'm going back to a previous problem we did earlier. When I did this right here, look, x squared equal 9. How do we get x by itself? Square root. Well, we did square both sides, we did what? Square root. We do the square root of both sides. But what am I doing to x right now? Squaring. What's the opposite of squaring? Square rooting. But remember, we took the square root of both sides, we had to do that plus or minus, right? So my solutions were plus or minus 3. Y'all agree?
Yeah.
All right. Now, let's go back to this one. Let's think of a process I can go through. So I did this one by inspection because I knew the square root. Well, some of us knew the square root of 9 was 3. But let's talk about a process, though, just like we did x squared. So we did x squared equal 9. We knew you had to do the square root of both sides because what's the opposite of squaring? Square rooting. Well, now, in that equation, I'm taking the square root of x. So what's the opposite of square rooting? Squaring. So you're going to square both sides. Just like this. So you got to make the connection with things you've already done, the processes you've been through. And so the square and the square root, just like we did previously, undo each other, inverse operations. And so I get x to be what? 9. Okay? So when you have a square root equation, to get rid of that square root, you're going to do what to both sides? Raise both sides to the second power. Okay? What if you had this? Now, the ones that we're going to deal with are going to be square roots, but I'm just out of curiosity. What if you had this? Cube root of x equal 2. Now, you can do that by inspection. Cube root of what number is 2?
8.
8. Let's do the process. And how can I get rid of that cube root? Raise it to what? Third power. The opposite of cube rooting is what? Cubing. Cubing. So I want you to look at the connection between this one and this one. So I cube both sides. So notice when I raise both sides to a power, what I raised it to was the same as the index. So that's why when you solve a square root equation, what's the index? 2. So you're going to raise both sides to the second power. If the index was 5, you'd raise both sides to the 5th power. The index was 7, you'd raise both sides to the 7th power, so on. Okay? So when we get to this point here then, oh, and by the way, the cube and the cube root undo each other, so you get x to be what? 8. So when we get to number 1, the square root's by itself. I want to get x by itself, though. So I got to get rid of the square root. What's the next step? Square both sides. That's x minus 5. Whenever you're not sure, you probably just say it's a 5. So I'm going to write this over. So you're going to square both sides, just like that. Very simple. The square and the square root undo each other. What expression is left? X minus 5. And what does that equal? That's a 5. And now notice I went from a radical equation to what kind of equation?
Linear.
Linear. One step and you're done. What do I do next? Add 5 to both sides. So what's your solution?
X equals 14.
X is 14. You're done. So next class period, we're going to do more like this where the radical is not by itself, but it's no big deal. You do the same way you did with the square root properties. You get it by itself. But notice we're saying X is 14, right? So let's just kind of check that real quick. You go back to the original. What's 14 minus 5?
9.
And what's the square root of 9? 3. So 14 works. All right, so that was just a quick start on what we're going to do next class period. So we'll do more with this next class period. Yes? Oh, good question. So when we did this one, why wasn't the answer plus or minus 9? I'm sending it back to you. Why isn't the answer plus or minus 9 here? Because if you did say -9, what's the square root of a -9? You go back and you check. What's the square root of a -9?
3i.
3i. Is that a 3i? No, it's a what? 3. So that's why when you raise both sides to an even power, you don't deal with the plus or minus. It's only when you take the square root. Yeah, but that's a good question. So notice that when I take the square root of both sides, that's where you get the plus or minus. When I square both sides, you don't do that. And it kind of makes sense because if I said plus or minus I know that's not true because the square root of a -9 is not 3. Only the square root of 9 is what? 3.
And how did you check if it was correct?
You go back to the original. 14 minus 5. What's 14 minus 5? 9. And what's the square root of 9? 3. Okay? Yeah. All right? Okay, so what I want you to do now is to take those worksheets, and you still have about 10 minutes,